Welcome to CS Course Companion. So, have you ever wondered what a self-driving car, a Roomba, and maybe even a video game character have in common? Well, they're all built on one of the most fundamental ideas in AI. And today, we're going to build one from scratch. Let's talk about the AI agent.
Okay, let's kick things off with a little puzzle. What could a little robot vacuum, a ghost from Pac-Man, and a Tesla possibly have in common? On the surface, they seem totally different. But believe it or not, they all operate on the exact same core principle. And the answer is, they're all AI agents. So in the next few minutes, we're not just going to give you a textbook definition. No, we're going to actually build one right from the ground up, piece by piece. And in doing that, we're going to reveal the essential blueprint that powers so much of the AI you see today.
All right, so it's time to lay our foundation. Before we can really get into the whole AI part of this, we've got to understand the agent part. So what exactly is an agent?
The core idea is actually pretty simple. An agent is really just anything that can perceive its environment, see what's going on around it using sensors, and then act on that environment using what we call effectors or actuators. For us humans, our eyes and ears are the sensors, and our hands and legs are our effectors. For a robot, it's just cameras and motors. It's the same basic concept.
And this diagram here shows that fundamental loop perfectly. You've got the agent, it perceives the environment through its sensors, it processes that information, and then it acts on the world using its actuators. Sense, think, act. That's it. That's the core cycle of literally any agent.
Okay, so now let's build our very first, most basic type of agent. This is really the first building block in our AI blueprint. This little guy is a simple reflex agent. Its entire brain is just a set of what we call condition-action rules. It's pure if-then logic. If my sensor sees a wall, then I turn left. If the car in front of me slams on its brakes, then I brake. Super simple, direct reactions.
Now the key thing to really get here is that this agent is all reflex. There's no memory. It only knows what's happening in this very instant. It has absolutely no idea what happened even a second ago, which, as you can imagine, is a huge limitation if we want to build something that feels truly intelligent.
So to get past that limitation, we need to add our second block. We have to give our agent some kind of memory, and we do that by introducing the concept of state.
And hey, if you've been following our operating system series, or maybe you've taken a digital logic course, this whole idea of state should sound really familiar. It's basically the system's memory, a snapshot of its condition based on everything that's happened before. It's a perfect example of how these core CS concepts just pop up everywhere.
And this is how we actually do it. Check out the new components in this diagram. See, we've added a box for state, one for how the world evolves, and another one for what my actions do. All of a sudden, our agent has this internal model of how it thinks the world works.
This upgrade, going from a simple reflex agent to a model-based one, is a massive leap. We go from just reacting to what's happening right now to actually maintaining an internal understanding of the world. It can now reason about things it can't even see at this moment, all based on what it remembers.
Okay, so our agent can perceive, and now it can remember. Let's give it our third block, a purpose.
A goal-based agent knows its destination. It uses these really powerful techniques like search and planning, which are just fancy algorithms for exploring future possibilities, to find a path to its goal. Think of it like solving a maze. But here's the catch. It only cares about getting to the goal. It doesn't really care if it takes the smartest path or some ridiculously long, winding route.
And that, right there, brings us to our final and most sophisticated building block, making our agent not just effective, but also efficient.
This is where the utility-based agent comes in. This agent doesn't just have a goal, it has preferences. It actually assigns a utility score to different states of the world. You can think of it like a happiness score. Its whole job is to choose the action that leads to the state with the highest possible utility.
This quote really just gets to the heart of it. Just reaching a goal isn't enough for high-quality behavior, right? A self-driving car's goal is to get you to your destination, sure, but you also want it to get there safely, quickly, and smoothly. Utility is the thing that lets an agent weigh all those trade-offs and choose the best path, not just any path.
Okay, let's put this all together. We've just assembled the complete blueprint, our entire roadmap for building an intelligent agent from the ground up.
So we started with a simple reflex agent that could only react. Then we gave it a memory, creating a model-based agent that could remember.
After that, we gave it a purpose with a goal-based agent that could pursue an objective. And finally, we gave it preferences, which created a utility-based agent that can optimize for the best possible outcome. React, remember, pursue, and optimize. That's the blueprint.
And there you have it, the 4 fundamental building blocks of AI agents. If this blueprint helped you understand how AI works on a deeper level, make sure you're subscribed for more explainers from CS Course Companion. And definitely let us know in the comments what complex CS topic we should build from the ground up next. So now, when you look at the AI shaping our world, from simple little bots to incredibly complex systems, you can see this blueprint at work. The question I want to leave you with is this. Now that you know the blueprint, which of these building blocks do you think will be the most crucial in defining our future with AI?